Okay, so for this example on stationary point, it's not just about executing the method to get stationary point. So in this question, you realize that you will need to find two unknown first. Okay, so if there's always a question that you need to find two unknown, usually it needs two pieces of information. So the two pieces of information will allow you to form two simultaneous, and then it leads you to find A and B. Okay, so a lot of time, a lot of students, they may not be able to get the two equation. So they may only get one equation. So let's have an idea how we apply stationary point here. Okay, so when we see a coordinate, so the coordinate is in an implication that when x is 2, y is equal to 7. So essentially that will be the first piece of information. So that should be the first equation. Okay, so some people, they may not see this information. Some of you might see the other one. So some of you, right, if you're very sensitive to the idea of stationary point, you will remember that stationary point is dy dx equal to 0. But dy dx equal to 0 when x is equal to 2. So this will be the second equation. So from these two concepts, you actually form out two equations. Do your simultaneous to get your A and B. So it's quite a lot of things involved. So if we want to make things easier, right, we will just start with the coordinate first. Okay, so I will sub the coordinate inside. I will be getting something like this. Okay, multiply by 3, you get one equation. So for getting equation, of course, you get method mark. Okay, now the second part, you need to apply dy dx. But in the first place, you realize you didn't even have your dy dx. So make sure you can see that it's a chain rule for this part. So you got to do some indices first, which I have just done. So I can do my bring down power, minus power, and also my chain rule. So it should lead you to get a nice dy dx. So of course, if your dy dx is wrong, when you try to sub in your concept of stationary point, you will not get it correct. So when the whole A and B is not correct, the subsequent part is very difficult for you to earn any marks. Okay, so when x is equal to 2, dy dx equal to 0, the reason is because it is a stationary point. So put in the values. You will get an equation. Okay, so if you solve 1 and 2, it shouldn't be an issue for you to get the answer. Okay, I will not be showing. So that's your two equation, how to get your A and B. So that should help you to go on to the second part. So you realize the second part is asking for the other stationary point. So currently you already got one stationary point, 2, 7. So they are asking you for the other one. So if you already gotten your A and B, okay, return your A and B. So I'll return it to my Y first. And then I return it to my dy dx. So this is another idea of stationary point. So you just execute your dy dx equal to 0. Okay, I will not show the algebra. You will successfully get 2 points. You must recognize that one of the point is A, because this the x coordinate 2. So we wanted the other point. So you check out the coordinate by putting back into the y equation. So you will get the other stationary point. Don't blindly do out the two point. Okay, we are interested in the other one. Okay, then in the last part, you are supposed to determine whether your stationary point at A is maximum or minimum. So we are testing the A. So you got a choice. Do you want to do the first derivative or do you want to do the second derivative? So in this case, you can check out your first derivative first. If you find that it's quite easy for you to differentiate one more time, okay, then you go ahead. So I choose to differentiate one more time. Okay, so I will not show you the working. So I successfully gotten my second derivative. Okay, please try getting the second derivative. And then when I got the second derivative, I'll be testing the x coordinate of A. So I insert the coordinate of A and I got a positive value. So my conclusion is that it's a minimum point. Okay, so it will end up to be quite a long question. Okay, and obviously a lot lies with whether you can find A and B or not. Okay, so there is also another type of question in the third stationary point section where they ask you to show whether it show that it has neither maximum or minimum. So one approach, right, will be, okay, you do stationary point. You try to do stationary point. So do a dy dx, and then you end up no solution. So one approach will be you do your stationary point, you do a dy dx equals 0, and you end up no solution. So since there are no solution to dy dx equal to 0, then then the equation or the curve does not have maximum or minimum point. So this is one approach that you can do. So if a question asks you why it doesn't have a turning point or why it doesn't have a maximum point or minimum point, you do as per normal. So you do as if they ask you to find stationary point, but you end up no solution. So that's one way. Okay, you can try in this way. Another way is to explain that it's an increasing or decreasing function, because increasing or decreasing function also doesn't have a maximum point or minimum point. Okay, so if I'm going to go by the approach of increasing or decreasing function, I still need my dy dx. So either way, if my approach is to do the stationary point or to do the increasing or decreasing function, I still need my dy dx. So you set out to do your dy dx first, no matter what. Then you decide what kind of explanation. So in this case, you should be doing your quotient rule. Okay. So I'm not showing you the quotient rule. So if you work it out yourself, you actually got quite a nice function. I think I got something like this. Okay, so with the dy dx, I can go by the two approach. I can go by the increasing decreasing function approach, or I can do a stationary point approach. So I will show you both. So if I'm going to go by the increasing and decreasing function approach, okay, I will do an explanation. I will target the perfect square. So the denominator is always positive. The numerator is already a positive. So the whole fraction ends up to be positive. And that is your dy dx being positive. So since the dy dx is always positive, then y is an increasing function. So you cannot stop at the increasing function. You got to tell me the implication of an increasing function. So because it's always increasing, it does not have a maximum or minimum point. So that's my approach. The other approach, let's try to do a dy dx. After I got my dy dx, so I'm trying to get a stationary point. So you find that if you try your cross multiplication, you actually end up something like this. If you try the cross multiplication. So it actually doesn't work. So, but do not show the 1 equal to 0. Okay, please don't show the 1 equal to 0. So there are no solution. So there are no solution to dy dx equal to 0 as the denominator is always positive. So it doesn't have, so the curve doesn't have any maximum or minimum point. But do not show the 1 equal to 0. Okay, you can just explain that there is no solution. So you can approach it by the increasing or decreasing function way, or you can do a dy dx equal to 0 and end up no solution. Okay, so that's the way we explain why the equation doesn't have stationary point. It can be quite a common question. So you execute your stationary point and you get no solution. Or you can go by the increasing or decreasing function approach.